Okay, let's look at a couple different ways that you could have approached this problem. So the first would be just recognizing that we have, in each case, we have a square, and on top of that we have a rectangle, and they're growing in predictable ways. So the square is just growing so that it's got the same number of columns and same number of rows as n. So that means that the size of the square is just going to be equal to n squared. And that's going to stay true as we continue through n is equal to 100. Then we also have this set of this triangular pattern here. And another way to write this would be to look like this. So we have 3, and it looks like this. Well, another way to think about this is that it's equal to, let me make these dots look like this. So if we put this triangle together with its reflection or its rotation, we can see that we have two of them, and they're going to be equal to 4 times 3, and that is when n is equal to 4. So in other words, we have a rectangle that has dimensions n times n minus 1, and the triangle is going to be exactly half of that. So that means that the size of the triangle will be given to us by this. So we have the number of dots in the square given to us by that, and the number of dots in the triangle given to us by that. Now another way to look at it is if we look at the number of dots in each pattern. We have pattern number 1, 1 dot. We have pattern number 2, we have 5 dots. We have pattern number 3, we have 12 dots. And when we have pattern number 4, we have 22 dots. So if we look at the differences here, we went up 4, then 7, then 10. Notice that our difference of differences is constant. And as we talked about the other day, that means that we have a quadratic. And that means that we can express this quadratic as ax squared plus bx plus c. So that means we can say that our number of dots, let's call that y, is equal to a times x squared plus bx plus c, where x is equal to the figure number, or n. So now we can say that 1 is equal to a times 1 squared plus b times 1 plus c. 5 is equal to a times 2 squared plus b times 2 plus c, and therefore 12 is equal to a times 3 squared plus b times 3 plus c. Well, when we write that out, we're going to get that 1 is equal to a plus b plus c. 5 is equal to 4a plus 2b plus c. And 12 is equal to 9a plus 3b plus c. Okay, so what does this mean? We have 3 unknowns, a, b, and c, and 3 independent equations. So that means that we have enough information to solve, and so what we're going to do is we're going to use elimination. We're going to first find 2 different equations that just have a and b. Well, one of the things that makes this easier is that in each case we just have c. So if we subtract the second equation minus the first equation, we're going to get 4 is equal to 4a minus a, or 3a, and 2b minus b, or just plain b. Then when we subtract the third equation minus the second equation, we get 12 minus 5, or 7, is equal to 9a minus 4a, or 5a, plus 3b minus 2b, or just plus b. And so now we have 2 equations with 2 unknowns, a and b. Now let's subtract the first equation from the second and get 3, 7 minus 4, is equal to 5a minus 3a, or 2a, and the b's cancel out. So we get a is equal to 3 over 2. Okay, well now that you have a, you can plug back in to either one of these equations to get b. And then you can go and plug, once you have b, go plug it in to any one of these 3 equations up here. to figure out the value of c. Once you have that, you'll have your equation where the number of dots is going to be equal to some number a, which we actually know now to be 3/2, times n squared, plus some number b times n, plus some number c. And then when you plug in 100 for n, you'll get the number of dots in the 100th pattern.